this video, we're going to discuss about convergent sequence. So bago tayo pumunta sa convergent sequence, i-review lang muna natin yung definition ng sequence. So ano nga ba yung sequence? And sequence, that is a function from D to R, where D, yan yung set of yan yung domain, tapos yung R, yan naman yung range. Okay? Set of values of X, tapos set of values of Y. With D, subset of natural numbers, set of natural numbers, and yung R, subset naman ng set of real numbers. Okay? So for our notation, ang gagamitin natin sa discussion natin ng sequence at sa mga susunod pa, ay gagamit tayo ng parenthesis. Kasi ganyan, A sub n, to denote the sequence, instead of using braces. Or ganito, A sub n from 1 to infinity, or ganito, A sub n element of set of natural numbers. So kahit alin sa tatlong yan, yung ating notation for sequence. Now for example, we have the sequence 1 over n from 1 to infinity. So this is equal to, isa-substitute mo lang from 1 dito sa 1 over n. Okay? So 1 over 1, that is 1, 1 over 2, 1/3, 1/4, and so on. Okay? So ito yung example ng ating sequence. So proceed tayo sa definition ng convergent sequence. For definition, a sequence A sub n is said to converge to L, real number L, if for every epsilon greater than 0 there exists a natural number n such that as n greater than or equal to large N, the distance between A sub n and L is smaller than epsilon. So we write limit of A sub n as n approaches infinity equals n, or the sequence A sub n converge to L as n approaches to infinity. Okay? So, ano yung gustong sabihin yan? Masasabi na natin na ang sequence ay nagko-converge or nag-a-approach sa real number L kapag daw for any distance known as epsilon, so this is always positive, palagi tayong makapagpo-provide ng natural number n such that as the values of n becomes larger than this large n, then yung distance ng A sub n tsaka L becomes smaller and smaller and becomes smaller than this distance, epsilon. Okay? So kapag nangyari yon, we can write that we can say that this sequence is convergent and is said to converge to L. Or in other term, we can write or we can say that the limit of A sub n as n approaches infinity is equal to L. So, kumbaga dalawa yung definition natin dito, definition of convergent sequence at definition ng limit of a sequence. Okay? To further illustrate the definition of convergent sequence or limit of a sequence, so take note yung huling sinabi doon, yung absolute value of A sub n minus L less than epsilon. So this is equivalent to negative epsilon less than A sub n minus L less than epsilon. Okay? Kung i-apply natin yung property na absolute value. And this is also equivalent to kung ililipat natin tong negative L sa both sides, or magpa-plus tayo ng L sa lahat ng sides na yan. So meron tayong L minus epsilon less than A sub n less than L plus epsilon. And this is equivalent to A sub n belongs to the open interval L minus epsilon L plus epsilon. Okay? Now, so let's say meron tayong number line dito. Okay? Then, let's say meron tayong point L. Kung mamimili tayo ng epsilon, so kahit anong epsilon, let's say dito, magsaset tayo ng epsilon. So, this is epsilon. This is epsilon. So, ibig sabihin, ito ay L plus epsilon, ito ay L minus epsilon. So, dito, meron tayong nabuong interval na L minus epsilon, L plus epsilon. So, according to our definition, so, yung sequence niya ay convergent kapag, for example, nandito yung A sub 1, nandito yung A sub 2, nandito yung A sub 3. So, kahit alin dyan sa labas ng interval. So, nandito yung A sub 4. Then, kapag umabot na tayo sa N, okay? So, from N or as small n becomes larger and larger than N, capital N. So, let's say, dito, papasok na siya dito sa loob ng open interval. So, magiging nandito yung A sub N. Then, let's say, nandito yung A sub N plus 1, A sub N plus 2, A sub N plus 3. So, mula dito sa A sub N, mula sa A sub N, hindi na siya lalabas dito sa loob ng interval. Okay? From A sub N pataas, A sub N plus 1, A sub N plus 2, A sub N plus 3, and so on, palagi na siyang element ng L minus epsilon, L plus epsilon. Okay? So, palagi na siyang nasa loob. Wherein, ibig sabihin yan, kung nasa loob na yan, yung distance niya becomes smaller than, yung distance niya dito sa L becomes smaller than epsilon kasi hindi na lumalabas dito sa open interval. Okay? So, yun yung sinasabi ng convergent sequence at limit of a sequence. So, sa ganito, masasabi natin na yung limit ng A sub n as n approaches infinity is equal to L. For another illustration about definition of convergent sequence, kung sakaling nalilito kayo sa illustration kanina, so meron akong another illustration dyan. So, halimbawa, meron tayong Cartesian plane. Yung x-axis ay set of natural numbers, mga points dyan. Tapos sa y-axis, set of real numbers. Then, let's say meron tayong point L dito. Then, kapag nag-choose tayo ng epsilon, kahit anong epsilon, take note, yung epsilon natin ay arbitrary. So, let's say, dito, let's say, dito yung epsilon, so ito ay L plus epsilon, L minus epsilon. Okay? Then, dapat makakahanap pa rin tayo ng natural number n, let's say, dito. Okay? Wherein, so i-extend natin to para makita natin yung itsura. Wherein, kung yung mga values ng A sub n dito ay nasa labas nito, okay, ng L minus epsilon, L plus epsilon. So, let's say nandito o kaya nandito. Then, after n na nakita natin, dapat yung mga values na ng A sub n nasa loob na. Okay, wala nang lumalabas dyan. Nasa loob na ng L minus epsilon, L plus epsilon. Kasi kapag nasa loob yan, kapag kukunin mo yung distance nun ng A sub n sa L, that is always less than epsilon. Okay, which is ito. Pero kapag may nakita ka dito, let's say dito, yan. Kapag kinuha mo yung distance ng A sub n na to sa L, this will become larger than epsilon. Okay? So, sa convergent sequence or sa limit of a sequence, palaging nasa loob na siya after natural number n. Para masabi natin na yung limit of A sub n as n approaches infinity equals L. Okay? Now, ang target natin dito, yung epsilon natin, paliliitin natin yan. Ang target natin, yung mas maliit na epsilon, yung mas dikit dito sa L. Okay? Now, habang lumiliit yung ating epsilon, yung natural number n na makikita natin becomes larger and larger. Okay? So, kapag magsaset tayo ng epsilon, paliit ng paliit, yung n natin, lalaki ng lalaki. Okay? Pero basta ang punto dito, para masabi natin na convergent ang isang sequence, dapat palagi tayo nakakakita ng n, gaano man kalaki to, or gaano man kaliit yung iset mong epsilon. Okay? So, ganun lang kasimple intindihin yung definition of limit. So, i-apply natin siya sa example. So, for example, prove that limit of 1 over n squared as n approaches infinity is equal to 0. So, bago tayo mag-prove, let's have discussion first. So, ibig sabihin yan, for any epsilon greater than 0, dapat makapag-provide tayo ng natural number n such that as n becomes larger and larger than n, okay, the distance between a sub n and L, which is the distance between 1 over n squared minus 0, becomes smaller than epsilon. Okay? So, ang target natin, dapat makapag-provide tayo ng natural number n na magsasatisfy dito sa condition na to. Okay? So, paano natin gagawin yan? Ito yung imamanipulate natin. So, consider distance na to. So, 1 over n squared minus 0. So, this is equal to absolute value of 1 over n squared. Okay? And this is also equal to 1 over n squared. Sir, bakit? Kasi yung n, natural number yan. At kahit hindi yan, kapag in-square mo, positive talaga yan. Kaya kapag kinuha mo yung absolute value ng 1 over n squared, palaging positive yan. By definition of absolute value, that is 1 over n squared. Okay? And take note that this 1 over n squared is equal to this 1 over absolute value of 1 over n squared minus 0, which is less than epsilon. So, this is less than epsilon. Okay? So, kung i-square root natin both sides, this implies 1 over n less than square root of epsilon. Okay? Tapos, pagpalitin lang natin to, so yung n, lagay natin dito, yung square root of epsilon dito. So, this implies 1 over square root of epsilon less than n. Or, n greater than 1 over square root of epsilon. Okay? So, by Archimedean property, kung naalala nyo yung Archimedean property, ang sabi doon, for any real number, palaging may natural number na mas mataas sa kanya. Since 1 over square root of epsilon is a real number, makakahanap tayo ng natural number na mas mataas dito. And let's say yung natural number na yon ay capital N or large N. So, large N greater than 1 over square root of epsilon. Okay? So, let's say ito yung ating large N. So, proceed tayo doon sa proof nito. Okay, for our proof, let epsilon be greater than 0 and choose large N to be greater than 1 over square root of epsilon. Okay, so ito yung ginawa natin kanina, no? So, ang kailangan na lang nating patunayan, so we have to show that as small n becomes larger than n, yung distance ng 1 over n squared minus 0 must be less than epsilon. So, ito yung dapat nating mapakita. Okay? Now, n greater than or equal to n implies n greater than 1 over square root of epsilon. Kasi, yung large n natin, pinili nga natin large n is yung natural number na greater than 1 over square root of epsilon. So, kung yung small n greater than or equal to large n, then, of course, yung small n na to ay greater than 1 over square root of epsilon. Okay? Then, kung i-square natin both sides to, magiging ano siya? n squared greater than 1 over epsilon. Then pagpalitin natin, magiging ano siya, epsilon greater than 1 over n squared. Or 1 over n squared less than epsilon. Okay? But since yung 1 over n squared ay equal sa absolute value of 1 over n squared, which is also equal to absolute value of 1 over n squared minus 0. Kumbaga pa backward tayo, no, sa ginawa natin kanina. Okay? Then this proves that yung absolute value of 1 over n squared minus 0 is less than epsilon. Okay? For all n greater than or equal to n. So, ibig sabihin, limit of 1 over n squared as n approaches infinity equals 0. So, we are done. Okay, number 2, prove limit of 3n plus 1 all over 7n minus 4 as n approaches infinity is equal to 3 over 7. Or, i-prove natin na yung 3n plus 1 over, yung sequence na 3n plus 1 over 7n minus 4 is convergent. Okay? So, syempre, discussion muna tayo. Sa discussion natin, palaging ang ginagawa lang natin, hanapin natin yung large n. So, dapat makahanap tayo ng large n. So, let epsilon greater than 0, we need to provide large n such that for all small n greater than or equal to large n, the distance between 3n plus 1 over 7n minus 4, 7n minus 4 minus 3 over 7 becomes smaller than epsilon. So, hindi kita yung n. Basta 7n yun nandito. Minus 4. Okay? Now, ito ulit, dito ulit tayo mag-start. The absolute value of 3n plus 1 over 7n minus 4 minus 3 over 7. So, ang gawin natin, i-simplify natin to. Okay? So, this is equal to, i-times natin tong 7 dito, i-times natin tong 7n minus 4 dito, tapos i-times natin yung 7 tsaka 7n minus 4. Okay, dito, i-distribute natin, magiging ano yan, 7 times 3n, 21n, 7 times 1, that is positive 7. Tapos, 7 times negative 3, 7n times negative 3, that is negative 21n. Tapos, negative 4 times negative 3, that is positive 12. Over, wag muna nating i-times to. So, this is equal to, yung 21n minus 21n, cancel yan. Ang matitira, 7 plus 12. So, what is 7 plus 12? That is 19 over 7 times 7n minus 4. Then, this is also equal to 19 over 7, 7n minus 4. Since yung 7n minus 4 ay greater than 0. So, paano ka nakakasiguro na yung 7n minus 4 ay greater than 0? Kasi ang n natin ay natural number. Ang pinakamababa niyan ay 1. Imposibleng maging negative yan. Or imposibleng maging 0 yan. Okay? Now, kung dito tayo nag-arrive, so this is less than epsilon. Kasi ito, galing siya dito, which is ito, less than epsilon. Okay? So, this implies, i-manipulate natin yung 19, kahit ilipat natin yung 7n minus 4 sa dito. Okay, ganito ha. Ganito kasi yan, para hindi kayo malito. 7n minus 4, scratch ko lang, less than epsilon. Ililipat ko tong 7n minus 4 dito, tapos yung epsilon dito. Okay? So, 19 over 7 epsilon less than 7n minus 4. Okay? Then, ilipat ko tong minus 4 sa kabila. So, magiging ano siya? 19 over 7 epsilon plus 4 less than 7n. Tapos, divide ko both sides by 7. So, this implies 19 over 49 epsilon. Pag dinivide ko to ng 7 plus 4 over 7 less than n. Okay, makakancel na kasi yung 7 dito. Or yung n ay greater than 19 over 49 epsilon plus 4 over 7. Okay? So by Archimedean property, this is a real number. So pwede akong makakita or makakakita talaga ako ng natural number na greater than this real number. And let's say yung natural number na yon ay large n. So choose large n to be greater than 19 over 49 epsilon plus 4 over 7 by Archimedean property. So, punta tayo sa proof. Okay, for our proof, so let epsilon be greater than 0 and choose, ba't nilagyan ko ng tuldok? And choose large n to be greater than 19 over 49 epsilon plus 4 over 7, we have to show that for any n greater than or equal to n, absolute value of 3n plus 1 over 7n minus 4 minus 3 over 7 is less than epsilon. Okay? Now, n greater than or equal to large n implies n greater than 19 over 49 epsilon plus 4 over 7. Tama? Since yung small n na to ay greater than or equal to n at yung large n ay greater than dito, so sigurado tayo na yung small n na yan greater than dito. Okay? Mag-multiply tayo ng 7 both sides. This implies 7n greater than 19 over, ano to? 7 epsilon plus 4. So, lipat natin yung 4 sa kabila. Parang nagre-reverse process lang tayo. 7n minus 4 greater than 19 over 7 epsilon. So, ililipat ko yung epsilon dito, yung 7n minus 4 dito. Okay? So, magiging epsilon greater than 19 over 7 times 7n minus 4. Or, ano ko lang, 19 over 7, 7n minus 4 less than epsilon. But since yung 19 over 7, 7n minus 4 ay equal sa absolute value ng 19 over 7 times 7n minus 4, since yung n ay natural number, and this is equal doon sa original natin na 3n plus 1 over 7n minus 4 minus 3 over 7. So, yan yung kinompute natin kanina. No? Then, kung ito less than sa epsilon at ito ay equal dito, this proves that ito, absolute value of 3n plus 1 over 7n minus 4 minus 3 over 7 is less than epsilon. So, therefore, yung limit ng 3n plus 1 over 7n minus 4 as n approaches infinity is equal to 3 over 7. So, this is done. So, ganun lang siya kasimple. So, hanggang dito lang for convergent sequence or limit of a sequence.